Now we'll learn about what happens when an acid or a base is mixed into a water solution. So this must be the simplest kind of reaction, right? An acid simply plus water, or simply a base plus water. There's no other element into it. It's simple water, right? So it must have a very simple and basic reaction. So let's read it. The experiment said hydrogen ions in HCl are produced in the presence of water, and HCl is nothing but hydrochloric acid. So the separation of hydrogen ion from hydrochloric molecules cannot occur in the absence of water. So without water, the release of hydrogen ions from an acid is not possible. So what happens when an acid gets mixed with water? It releases hydrogen ions, and without water it is not possible, right? This is it. Hydrochloric acid plus water, that is H2O, releases H3O. I don't know what it is, maybe hydroxide, something like that, but chlorine here and chlorine. So these are nothing but hydrogen ions, right? Hydrogen ions are released here. So hydrogen ions cannot exist alone, as we very well know that hydrogen cannot exist in free state, and it needs to combine with something, right? But they exist after combining with water molecules. Now it has come in the form of water molecules, right? So thus hydrogen ions must always be shown as H plus or a hydronium ion. This is an hydronium ion. So H plus H2O is equal to, that is, this is hydrogen ion plus water. So hydrochloric acid here released hydrogen ions, and hydrogen ion got mixed with this H2O with water, and it formed H3O, hydronium ion, right? So hydrogen ion was initially released, but upon releasing it instantly mixed up or combined with water, that is H2O ions, thus forming H3O plus, that is hydronium ions, right? So the important thing to remember here is it that acid plus water is equal to release of hydrogen ions. It always, there would be definitely some reaction involved in it according to different kind of acids, but the basic or the main thing is that hydrogen ions are released, right? So bases and bases varies. In the other case, bases generate hydroxide ions. Hydroxide, it is hydrogen oxygen mixed combined ions in water. So when you mix a base with water, a pure base with purely water, nothing else, it would release hydroxide ions, right? And bases which are soluble in water are called alkalis. Alkalis are nothing but bases that are soluble in water. Okay, so this is, we already know acid plus base is equal to salt plus water, right? You can read this activity and do it by yourself. You can read this also. This is nothing but telling us about diluted and undiluted acid. Diluted acid, that has a less concentration of acidic ions per unit, and undiluted acid is that has a higher concentration of acidic ions per unit, right? That's undiluted acid. Undiluted is nothing but pure acid, and diluted is unpure acid or mixed with something else too. And what is the scale for measuring how strong an acid or base is? It is a pH scale. pH means hydrogen indicator scale, right? So the number of hydrogen ions present in it will define whether it is a strong acid or a base. If it has a lot of hydrogen ions, then as we already know that acid releases hydrogen in water. That means acid has hydrogen ions, and the more the hydrogen ions, the more acidic that substance is, and the less the hydrogen ions, the less acidic the substance is, or the more basic the substance is. So the values less than 7 on the pH scale represent an acidic solution, right? A scale for measuring hydrogen ion concentration in solution is called pH scale. The P in pH stands for potens in German, meaning power of H. On the pH scale, we can measure pH from 0, very acidic, to 14, very alkaline. pH should be thought of simply as a number which indicates the acidic or basic nature of solution. Higher the hydronium ion concentration, lower is the pH value, right? So it's not based on release of hydrogen ions, but instead hydronium ions, right? Hydronium ions means there are actually two ways of looking at it. You can either look it through hydronium ion concentration, or you can simply look it through hydrogen ion concentration, right? Both are accurate ways, but mostly we take pH. We have developed this method of pH, and we use hydronium ion formula for knowing whether an substance is acidic or basic, right? So the less the hydronium ions concentration, the more acidic the substance is, and the more hydronium ion concentration, the more basic the substance is, or less acidic the substance is, right? Because hydronium ions are present in what? Bases. It's not present in acid, right? So moving on. So these are some common pH values, pH or hydronium ion values. Our body works within the pH range of 7 to 7.8, right? So the pH range or the hydronium ion range in our body should vary from 7 to 7.8 for it to function normally and healthily, right? And our digestive system, this is something like, don't, you can just read it, it's not very important though. This is important, you just need to remember this one line, that the pH of the mouth is lower than 5.5. That is, our mouths are basically acidic because the hydronium ion concentration in our mouth is less than the neutral. It's neutral at 7, right? It is neutral at 7, or you can say around 7.5 something, 7 to 7.5. It's neutral around this point. You can say 7.4, 7.5, around that value it's neutral. It's neither acidic nor basic. Now one more point here that you should remember it is bee sting leaves an acid, and which acid is that? It's formic acid, FORMIC, formic acid. So bee sting contains formic acid, and that is why the irritation and the swelling. Now, in the next topic we'll cover the salts. Okay.